So in this video, I'm going to walk through the socio-technical model, a framework that helps explain why technology in healthcare often fails, even when it's technically sound. To really understand the healthcare systems, we need to look at both the technology and the people using it. That's exactly what this model helps us do. So what is the socio-technical model? The socio-technical model is a framework that views systems as both social and technical at the same time. On the social side, it considers people, culture, and workflows. On the technical side, it considers technology, tools, and infrastructure. The key idea is that systems only work well when these elements are designed together. So why does this model exist? Well, this model exists because many technology failures are not actually technical failures. Instead, they're failures related to people, workflow, communication, or organizational context. The socio-technical model helps us explain why systems that look good on paper often struggle in real-world use. At its core, the socio-technical model is built on two interdependent systems: the social system, which includes people, roles, culture, and communication, and the technical system, which includes hardware, software, data, and infrastructure. It's good to note that neither system works well in isolation, as they are constantly influencing each other as the system evolves and progresses. Which is why balance between these two systems is critical. When technology dominates, users often experience burnout, workarounds, or increased error risk. When social factors dominate, without technical structure, systems become inconsistent and difficult to scale. Success between the systems exists where social and technical elements are balanced. The socio-technical model can be applied to many different fields. Healthcare is one of the clearest examples of a socio-technical system. Electronic health records, patient portals, scheduling systems, clinical decision support, and new medical devices all interact with people and workflows. If these technologies don't align with real clinical practice, problems quickly emerge. To better analyze complex systems like healthcare, the socio-technical model is often broken down into 8 dimensions. These dimensions help us systemically examine how technology interacts with people, workflows, organizations, and the external environment, including both intended and unintended effects. The first dimension focuses on hardware and software. This includes computers, servers, devices, and the applications that run on them, such as EHR platforms. Even reliable technology can fail if it's slow, unstable, or poorly designed for its users. The next 2 dimensions are clinical content and the human-computer interface. Together, these 2 dimensions shape how users experience and interact with the system in real time. Clinical content includes things like order sets, alerts, documentation templates, and clinical decision support tools. These elements are designed to guide care, support decision-making, and improve patient safety. Whereas the human-computer interface refers to how that content is presented to users, including screen layouts, navigations, buttons, and visual design. This is the point where humans and technology directly meet. Even well-designed clinical content can create problems if the interface is poorly designed. Too many alerts, confusing layouts, or excessive clicks can increase cognitive load and lead to alert fatigue. When users feel overwhelmed by the interface, important information can be missed, not because users are careless, but because the system makes it harder to focus. The socio-technical model emphasizes that good design isn't just about what information is included, but how and when it's delivered. Effective clinical content and interfaces support users at the right time, in the right way, without getting in the way of care. Keeping all these in mind, it leads us to the next dimension: people. This dimension focuses on the people involved in the system, including clinicians, clerical staff, analysts, IT teams, and developers. Every one of these groups interacts with technology differently based on their roles, responsibilities, and work environment. People bring their own experiences, training levels, expectations, and pressures into the system. A system that works well for one group may be confusing or frustrating for another. In healthcare especially, people are often working under time pressure, cognitive load, or emotional stress. Technology that assumes ideal conditions or perfect use doesn't reflect the reality of clinical practice. And because of this, users naturally adapt systems to get their work done. They may create shortcuts, workarounds, or unofficial processes, not because they want to break the system, but because they need to function within it. The socio-technical model recognizes that people are not the problem to be fixed. Instead, people are an essential part of the system that technology must support. When system design aligns with human behavior and real-world conditions, adoption improves and risk decreases. When it doesn't, frustration and unintended consequences emerge. The next dimension is workflow and communication. This focuses on how work actually gets done day to day and how information moves between people and systems. Workflow refers to the real sequence of tasks people follow in practice, not just how processes are described in policies or training manuals. In healthcare, workflows are often complex, fast-paced, and constantly interrupted. Communication includes handoffs between staff, documentation, messaging, and informal conversations that help coordinate care. These communication pathways are critical for safety, continuity, and efficiency. See, when technology aligns well with the existing workflows and communication patterns, it can reduce effort and support better decision-making. However, when the systems disrupt workflow or add unnecessary steps, frustration can quickly build. In response, users often create workarounds to keep things moving. These workarounds may solve short-term problems, but they can introduce risk and reduce system reliability. The socio-technical model helps us to see the workflow and communication are not just side issues. They are central to how systems function in real-world settings. The next dimension focuses on internal organizational features, such as culture, leadership, or training. These factors shape how technology is introduced, supported, and used within an organization, and they strongly influence whether a system succeeds or fails. Even well-designed technology can struggle if training is inadequate, leadership support is inconsistent, or the organizational culture discourages feedback or adaptation. The socio-technical model reminds us that technology does not exist independently from the organization using it. It is embedded within the structures, values, and expectations that directly affect how people engage with systems. Dimension 7. External rules and regulations. So this dimension focuses on external rules and regulations such as privacy laws, accreditation requirements, professional standards, and vendor constraints. These external factors shape how healthcare systems are designed, implemented, and used, often influencing what is possible within a system. Regulatory requirements can add complexity, limit flexibility, or introduce additional documentation and oversight, but they also play an important role in ensuring safety, accountability, and standardization. The socio-technical model highlights that system design must account for these external pressures, as they directly impact how technology is configured and how people interact with it in practice. And finally, Dimension 8 focuses on measurement and monitoring, including both intended and unintended consequences of technology use. This involves tracking how systems perform over time, how they affect workflow, safety, and outcomes, and whether new problems emerge after implementation. Without undergoing measurement and feedback, issues such as inefficiencies, workarounds, or safety risks can persist unnoticed. The socio-technical model emphasizes that monitoring is essential for learning, adaptation, and continuous improvement, helping organizations refine systems based on real-world use rather than initial assumptions. So now that we have a base of all 8 dimensions, it's good to see how this model applies in practice. So take into consideration, imagine a new EHR module being introduced in a healthcare setting. From a technical standpoint, the module works exactly as designed, but clinicians quickly report that it slows them down and disrupts their workflow. A socio-technical analysis reveals that the issue isn't the technology itself, but gaps in training, mismatches between the system and real clinical workflows, and poorly designed alerts that increase cognitive load. This example highlights how system challenges often emerge from the interactions between the people, the process, and the technology, not from the technical failure alone. Examples like this show why the socio-technical model is so important. Rather than assuming technology alone will fix problems, the model helps organizations understand how people, workflows, and systems interact in real-world settings. By considering social and technical factors together, it supports better system design, improves adoption, and reduces unintended consequences. In healthcare, this lands to safer care, more efficient workflows, and technology that actually supports the people using it. So overall, the key takeaway is simple. Technology itself does not fix the problem. Lasting improvement comes from well-designed socio-technical systems where people, workflows, and technologies are aligned. When we understand and apply this model, we're better equipped to design systems that work in practice, not just in theory. So that's it for the socio-technical model. I hope this helps you guys. So please like and subscribe. Thank you.